Yeah, let's go ahead and give this first guy a try, where we simply want to evaluate the sum if we can, and talk about whether this thing is going to converge, diverge, you name it. Now I decided to start off with this one because anything dealing with like a natural log, again, kind of our intuition is out the door. But when I see something with a natural log and everything's kind of packaged up in there, then it's sometimes fun to play around with the various different laws of logarithms to see if there's other ways you could write this. So in this particular sum, if you use your laws of logarithms, which I'm definitely going to do, you can turn this into the natural log of n minus the natural log of n plus 1. And that, as you may notice, is following that telescopic form. It's like essentially we just have like this an term minus like this an plus 1 term, almost directly. And even if I wanted to make this more clear, I could start to write out what these terms even look like. So as n equals 1, my first term is going to have the natural log of 1 minus the natural log of 2. Then I could go ahead and plug in n equals 2. And now I have the natural log of 2 minus the natural log of 3. That'd be my second term. And you can see what will happen as we really just continue on down the line. Dot, dot, dot. So these terms will continue going on and on forever. So now comes the question of evaluating this sum. We can see that it's telescopic. And at this point, there's a really easy mistake that you could make that you want to avoid. When people see a series like this, they start to evaluate the terms, they start to group things. It's very natural. And they say, well, all of this stuff is equal to 0. The natural log of 0 is equal to 0. Oh, okay, I guess that's the entire value of my sum, and they're done. But you have to be careful because that is not what the value of this series is. We're really dealing with things that go off to infinity. We have to go back to the definition of what it means to have one of these series converge and use that to find its value. That is to say, we say that a series converges if the limit of the partial sums converges. So that's really what we're after. So in this particular example, I want you to think of the partial sums associated with this problem. So rather than taking this thing all the way out to infinity, what if we actually just took it out to k? We were just going to stop at some point. So n equals 1 all the way up to k of the natural log of n minus the natural log of n plus 1. It seems like a small change. It looks like we're going to get all the same terms, but the difference is that this thing will stop at some point. So minus natural log dot, 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 dot. Eventually there will be a last term in here, the natural log of k minus the natural log of k plus 1. And then I can be a little bit more confident on canceling some stuff out. So the natural log of 1, yep, sure enough, that is 0. The tail end of this one is going to cancel with the first part of this one, tail and first part of that one. So all of these really do end up canceling, except for that very last logarithm at the very end, that negative natural log of k plus 1. So there is a formula for my partial sums. If I'm adding these things up, I only add them up to the kth term, then I have a formula for what that will add up to. And now if I'm actually trying to evaluate this, if I'm actually trying to figure out what is the limit of this as k goes to infinity, now I can see that it really does amount to figuring out the value of these partial sums. And in which case, as k goes to infinity, this goes to negative infinity. That is to say, even though this is a nice telescopic series, stuff cancels out, this series does actually not converge. And the reason why it does not converge is because the partial sums go to negative infinity. They keep, arbitrarily getting big and negative. So be careful when you're working with these to make sure that you're really working from the what it means to converge to something. That technically you're saying that the partial sums are what's converging. Other things that you can use for intuition of why this thing is not equal to 0 is essentially, yeah, the first term is going to be 0. But if you were to sit there with a calculator, you'd always have some sort of negative value after that. Even though those negative values are very small, those are getting added in there.